Welcome everyone. In this video, I want to look at using enthalpy of formation, an extension of Hess's law essentially, but using enthalpy of formation reaction equations to calculate the enthalpy of reaction for another reaction. So we're told to calculate the enthalpy of reaction for 2N2 gas reacting with 5O2 gas to give 2N2O5 gas. And we're given that the formation enthalpy of liquid water is minus 285.8 kilojoule per mole, that for nitric acid is something, and then for some general reaction is that. And then we're just told, go about your business. So the important thing here is you need to go and write the formation reactions for the liquid water and for the nitric acid, because the reactions are then as follows, and then it becomes much more apparent what's happening. So H2 gas, you can look them up in your textbook. It's not some otherworldly knowledge that I'm using here, but you can also kind of figure them out. So H2 gas plus O2 gas gives you H2O in the liquid state, and we're given that it's the formation enthalpy. Remember, formation enthalpy just means it's the enthalpy for forming 1 mole of this compound in this state. So that's all the formation enthalpy refers to. 285.8 kilojoule per mole, or per mole reaction. Once again, you can shift between the units easily enough. Nitric acid. So nitric acid consists of hydrogen, nitrogen, and oxygen. So the only source of hydrogen is H2, only source of nitrogen is N2, and the only source of O2 is O2. So you just need to balance it in some kind of way to get H, N, and O3. So if you have H2, so let me show you perhaps how to get to this. You can use N2 gas, and you can use O2 gas. And you want it to form HNO3 liquid. You're told formation enthalpy, standard formation enthalpy is equal to minus 174.1 kilojoule per mole. Right? Left-hand side, you have two H's. Right-hand side, you have one H. But remember, the formation enthalpy is defined as per 1 mole of the thing on the right-hand side. So you balance on the left. So you make it a half here. Nitrogen, once again, you have 2 on the left, 1 on the right. So you make it a half here. Oxygen, you have 3 on the right, you have 2 on the left. So you want 3, but there's a 2, so get rid of the 2. That's as easy as that. That's how you write formation reactions. This is the only time you are allowed to write fractions in your equations, because you're trying to form 1 mole of water, 1 mole of nitric acid. In the other examples, or when you're balancing normally, you'll always write to say you don't have fractions. Formation enthalpies are just defined for 1, 1. So in other words, it's just that you write the equation and then you can go get rid of your fractions, but then you need to remember that this value will change associatedly because it is defined for this reaction as written. Okay, that's the important part. That's why you write the fractions in. And then we're given this equation. So maybe let me have it in 2O5 gas plus H2O liquid gives 2 nitric acid, HNO3 liquid. And we're given it has an enthalpy of reaction equal to minus 76.6 kilojoule per mole. Kilojoule per mole or kilojoule per mole reaction whatever you want. The formation enthalpies are normally given in kilojoule per mole because that means kilojoule per mole of species. And then you can adjust it between kilojoule per mole reaction in any kind of way that you want. Right, so now the question is, we want to get to this equation at top here. We want to get to that point. So we just need to recognize, okay, so on the right-hand side, we want this species, we want 2 of it, we want oxygen, so we want to get oxygen, we want nitrogen. Okay, so all of these have things kind of in the right place, but here's also oxygen. So we're going to have to see how we're going to figure that out. So let's think about this creatively. Right. So let's start with the easiest one, the one there at the bottom. We want 2N2O5, so I'm going to multiply it, but we want it in the product side, so we're going to say this is multiplied by -2. Then let's get rid of the fractions in this equation. We want 2N2, so let's multiply this equation by 4. How many oxygens do we have then? We have 6 then, but we only want 5. So okay, if we would then multiply this one by -2, we should be fine. Okay, so let's see if that works. I mean, you can of course go and do it step by step by step, but you'll see that's basically how you do it. You identify where's everything that you want, and you just ensure that they're on the right side, and then you just start checking everything. So going from the first one, we have -2, so it means with this side then has 2 liquid waters. Going to the next one, we're going to have 2H2 gas. Going to have 2N2 gas. We're going to have 6O2 gas. We're also going to have 4HNO3 liquid. That then goes to, I'm going to put it like that so we just have it on one screen. So the minus there, so that means 2H2 gas plus 1 oxygen gas plus 2N2O5 gas plus 2H2O liquid. Okay, and now we start cancelling. So 2H2O cancels with 2H2O, 2H2, 2H2, 2N2 remains, 6O2, 1O2, so that becomes 5O2, 4HNO3. Oh, I missed the 4HNO3 on the product side here. From this equation here, I missed that one. So luckily that one cancels. Whew, nearly thought there was a big issue here. Okay, and then we end up with 2N2 gas plus 5O2 gas, giving us 2N2O5 gas. Right, so now we just need to remind ourselves what we did with what. So it's -2 the formation enthalpy of water, times 4 the enthalpy of nitric acid, -2 the reaction enthalpy of that reaction. So the enthalpy of reaction for, I'm going to call it for N2O5 gas, is then minus 2 times the formation enthalpy of liquid water plus 4 times the formation enthalpy of nitric acid minus 2 times the standard reaction enthalpy of nitric acid, HNO3 liquid. And you should find the value of plus 28.4 kilojoule per mole or per mole reaction. Right, so that is what we have here. So positive numbers, it means it's an endothermic reaction. Interesting. That's essentially it. The important thing is, as always, using Hess's law to manipulate those equations. I think also using the formation reaction equations, how to write them, get them correct, because otherwise you're going to struggle to get the rest. But yeah, that is it for this example video. Thank you for watching, and I'll see you in the next video.